Good morning. Today, first of all, recall the formula of s plus s, s minus s, c plus c, c minus c. So first, sin A plus sin B is equal to 2 times sin into bracket A plus B divided by 2 into cos into bracket A minus B divided by 2. Short form is s plus s is equal to 2sc. Second formula, sin A minus sin B is equal to 2 times cos into bracket A plus B divided by 2 into sin bracket A minus B divided by 2. Short form s minus s is equal to 2cs. Third formula, cos A plus cos B is equal to 2 times cos into bracket A plus B divided by 2 into cos bracket A minus B divided by 2. Short form C plus C is equal to 2CC. And fourth one, cos A minus cos B is equal to minus 2 times sin into bracket A plus B divided by 2 into sin bracket A minus B divided by 2. Short form C minus C is equal to minus 2SS. Now, related to this formula, discuss some example. First question, cos 9x minus cos 5x upon sin 17x minus sin 3x is equal to, prove that minus sin 2x upon cos 10x. So here our question is given cos 9x minus cos 5x upon sin 17x minus sin 3x and prove that this condition. So now start from the LHS side. Now here in numerator term cos 9x minus cos 5x. So first of all apply the formula of C minus C. So C minus C is equal to minus 2SS, and in denominator term S minus S form is present, so apply the formula S minus S is equal to 2CS. So in numerator term apply this formula, and denominator term apply this one formula. So is equal to minus 2SS. In numerator term we can return minus 2 times sine into bracket 9x plus 5x divided by 2 into sine another bracket 9x minus 5x divided by 2 upon, in denominator term s minus s, that means 2cs. 2cs, that means here we can return 2 times cos into bracket 17x plus 3x divided by 2 into sine bracket 17x minus 3x divided by 2. Now after here in numerator term and denominator term 2 cancel out, so is equal to remaining term minus sine into bracket 9x plus 5x, that means 14x divided by 2, so here we can written sine 7x into sine 9x minus 5x divided by 2. So 9 minus 5, that means 4x divided by 2. So here we can written sine 2x upon, in denominator term, cos into bracket 17x plus 3x, that means 20x divided by 2. So 20x divided by 2, that means 10x into sine 17x minus 3x divided by 2. So again here we can written sine 7x is equal to, now sine 7x cancel out in numerator and denominator term, so remaining term is our answer. So answer is minus sine 2x upon cos 10x. Next question. Sine 5x plus sine 3x upon cos 5x plus cos 3x is equal to, prove that tan 4x. So again start from the LHS side. Here s in numerator term s plus s form is present and denominator term c plus c form is present. So here we can written s plus s, that means 2sc, and c plus c, that means 2cc. So in numerator term apply s plus s, that means 2sc form. So here we can written 2 times sine into bracket 5x plus 3x divided by 2 into cos bracket 5x minus 3x divided by 2 upon, in denominator term c plus c, that means 2cc formula apply. So 2 times cos into bracket 5x plus 3x divided by 2 into cos bracket 5x minus 3x divided by 2. So is equal to, now simplify this term. So is equal to 2 times 5x plus 3x divided by 2. So here, okay, first of all 2 we can cancel out in numerator and denominator. Now cos 5x minus 3x by 2, cos 5x minus 3x by 2, both terms same, so again cancel out this term. So remaining term sine into bracket 5x plus 3, that means 8x divided by 2. So here we can written sine 4x upon, in denominator term 5x plus 3x divided by 2. So again we can written cos 4x, and we know that sine upon cos, that means tan. So written here tan 4x is equal to our RHS side. Next question. Sin x minus sin y upon, in denominator term cos x plus cos y is equal to, prove that tan into bracket x minus y divided by 2. So again same process apply here. In numerator term s minus s form is present, so s minus s is equal to 2cs, and in denominator c plus c form is present, so here we can written c plus c, that means 2cc. So now start from the LHS side. In numerator apply this identity, so 2 times cos into bracket x plus y divided by 2 into sin bracket x minus y divided by 2 upon, in denominator term c plus c form is present, so apply the identity 2 times cos into bracket x plus y divided by 2 into cos x minus y divided by 2, so is equal to, now again here 2 to cancel out in numerator and denominator. Also cos x plus y by 2 upon cos x plus y by 2, so again cancel out this term, so remaining term only sin into bracket x minus y by 2 upon cos into bracket x minus y by 2, and sin upon cos, that means tan, so we can return tan x minus y by 2 is equal to RHS side. Next question. Question number 4. Sin x plus sin 3x upon cos x plus cos 3x is equal to, prove that tan 2x. So again start from the LHS side, but first of all interchange the position of this one. We cannot interchange, so also we can solve this example, but here first term is x, second term is 3x, here first term is x, second term is 3x, so and in between plus sign is present, so we can interchange the position of this term. So first we can written sin 3x plus sin x upon, in denominator term cos 3x plus cos x. Now here apply s plus s identity, s plus s, that means 2sc, and in denominator c plus c form, that means 2cc, so is equal to, now s plus s, that means 2 times sin into bracket 3x plus x divided by 2 into cos into bracket 3x minus x divided by 2 upon, in denominator c plus c, that means 2cc, so 2 times cos into bracket 3x plus x divided by 2 into cos bracket 3x minus x divided by 2, so is equal to, again here 2 to cancel out, this term also cancel out, so remaining term sin 3x plus x divided by 2, so here we can return sin 2x upon, in denominator term we can return here cos 2x, and sin upon cos, that means tan 2x is equal to RHS side. Next question. Cos 4x plus cos 3x plus cos 2x upon sin 4x plus sin 3x plus sin 2x is equal to prove that cot 3x. So now in this question total 3 term is present. In above all the question only 2 term is present, but in this question 3 term is present. Now see concentration in our proof. Our proof is present in form of 3x. So here 4x term is present, 3x term is present and 2x term is present. So cos 3x we can written in last, and first and third term we can written in first and second position. So arrange of this term cos 4x plus cos 2x plus cos 3x upon same method apply in denominator term, 3x term written in last and first and third term written in first and second position. So sin 4x plus sin 2x plus sin 3x. Now here two term is present, so in first two term apply the identity c plus c. So c plus c, that means 2c c. So here apply the identity c plus c, 2cc. And in denominator term s plus s form is present, so apply the identity in denominator term 2sc. So is equal to 2 times cos 4x plus 2x divided by 2 into cos in bracket 4x minus 2x divided by 2 plus in last term cos 3x, so we can written as it is cos 3x upon in denominator term s plus s, that means 2sc. So 2 times sine into bracket 4x plus 2x divided by 2 into cos bracket 4x minus 2x divided by 2 plus last term again here we can written as it is, so sin 3x. Now simplify this term. Here 2 and here 2 is present, but we cannot cancel out this term because here in plus last term is present. So that's why we cannot cancel out this 2 and means 2. Now simplify this term. So 2 times cos 4x plus 3x divided by 2. So 4x plus 3x divided by 2 means 6x divided by 2. So here we can written cos 3x into cos 4x minus 2x divided by 2. So here written cos x plus cos 3x upon in denominator term 2 times sine 4x plus 2x divided by 2, so sin 3x into cos 4x minus 2x divided by 2, so cos x plus sin 3x. Now after in numerator term which term we can take common, so cos 3x we can take common. So remaining term 2 cos x plus 1. Now in denominator term sin 3x we can take common. So remaining term 2 cos x plus 1. Now 2 cos x plus 1, 2 cos x plus 1 cancel out numerator and denominator term. So remaining term cos 3x upon sin 3x and cos 3x upon sin 3x, that means cot 3x. So our answer is we get cot 3x RHS side. Now today our topic is discuss the formula of sin 2a, cos 2a and tan 2a. So now discuss this formula. So first formula, sin 2a. Sin 2a is equal to 2 times sin a into cos a. Now suppose 2a in place of sin 4a is present. So how can we apply this formula? So sin 4a in place of, we can written this as sin 2 into bracket 2a. Now again same formula apply here. So 2 times sin 2a into cos 2a. Next formula, cos 2a. Now cos 2a written in three way. So first formula, cos 2a is equal to cos square a minus sin square a. Now same formula written in another way, cos 2a is equal to 2 cos square a minus 1, and third formula, cos 2a is equal to 1 minus 2 sin square a. So how first formula cos square a minus sin square a, but remaining two formula how can be written? So now let us discuss the proof of this result. Cos 2a is equal to, here given cos square a minus sin square a. Now we know that sin square theta plus cos square theta is equal to 1. So cos square theta in place of written 1 minus sin square theta, right? So is equal to, here cos square a in place of written 1 minus sin square a minus sin square a is equal to 1 minus sin square a minus sin square a, that means 1 minus 2 times sin square a. So our proof is cos 2a is equal to 1 minus 2 sin square a. Now second result, cos 2a is equal to 2 cos square a minus 1. So same concept apply here. Sin square theta is equal to, we can written 1 minus cos square theta, and here sin square a in place of written 1 minus cos square a. Now simplify this term, so we get second result. Okay. Now third formula, tan 2a is equal to 2 tan a upon 1 minus tan square a. So now related to this formula, discuss one example. Sin x minus sin 3x upon sin square x minus cos square x, and prove that 2 times sin x. So first of all, in numerator and denominator, both this term minus sign we can take common. So in bracket sin 3x minus sin x upon, in denominator term also minus sign we can take common. So cos square x minus sin square x. Now after minus sign cancel out in numerator and denominator. So in numerator here apply the identity s minus s. So s minus s is equal to 2cs. and in denominator discuss the identity cos 2a is equal to cos square a minus sin square a. So in denominator term here using by this result and numerator term apply the identity 2cs. So is equal to 2 times cos into bracket 3x plus x divided by 2 into sin bracket 3x minus x divided by 2 upon in denominator term here apply the result cos square x minus sin square x, that means cos 2x. So in denominator written cos 2x. Now simplify this term. So 2 times cos 3x plus x means 4x divided by 2. So cos 2x into sin 3x minus x, that means 2x divided by 2 means sin x upon cos 2x. Now cos 2x cancel out in numerator and denominator term. So remaining term is 2 sin x is equal to RHS side.